Welcome guys. This is a question on work. The question says, in the figure 6.1, assume that the object is being pulled along the ground by a force or by a 75 Newton force directed at, let's say 28 degrees above the horizontal. How much work does the force do in pulling the object? 8 meters. Okay, so one thing that you need to know when it comes to work, you know that work is a product of force. Work done is the product of what? Force and what? The distance. Now the force and the distance should be in the same direction for work to be. In short, let me not say it's in the same direction. They must be parallel to one another for work to be done. Distance and the force should be parallel to one another, or in short, the displacement. Okay. Now, when we look at here, they have given us an angle of 28 degrees. That means we need our y component and our x component. And we are only interested in the x component, the f cos theta, because the distance is along that direction. So we are also looking for the x component here, not the y, right? Because this is the distance, so we need the force, the fx. So how do we get fx? So here we are saying the force we're interested in is fx multiplied by the distance. Now because we have an angle here, theta, how do we do? Remember on vector resolution, the x component is always associated with cosine, and the y component is always associated with what? With a sine. But like I said, we are not interested in the sine. We want, so in the y, we want the x direction. So we are going to get the x direction only, which we know that fx, in this case, fx will just be equal to f, this force here, cos theta. So here I'm going to replace f cos theta, then multiply by what? Distance. So f is what? 75 newtons. So we put 75 here. Then we put cos what? 28. Then our distance is 8 meters. So let's get a calculator. So we have cosine of 28 multiplied by 8 multiplied by 75. So I'm getting a distance, sorry, a work done of 529.768, I'll just say 0.8 Newton meter. Like that. Or you can say 529.8 joules. You're welcome.